Hello, in this video we are going to see L'Hopital's rule, and this is actually a rule which helps us to take the derivatives whenever we have a quotient f over g, and when we take the limit 0 over 0 comes, or infinity over infinity is the result at first, then this rule helps us to take the limit after taking the derivatives. Like, it states that if f and g are two differentiable functions, and if the limit of f over g as x goes to a gives us 0 over 0 or infinity over infinity, or maybe minus infinity over infinity, same, then this limit f over g as x goes to a is just equal to the limit still x goes to a, but this time f prime over g prime. So we take the derivative of the top and then we divide by the derivative of the bottom. So be careful here, this is not quotient rule, this is L'Hopital's rule. So we take the derivative of the top and we divide it by the derivative of the bottom, and we take the limit again until we get some result other than 0 over 0 or infinity over infinity. By the way, 0 over 0 or infinity over infinity, these are called indeterminate forms. We are going to see other types of indeterminate forms, and again, using L'Hopital's rule, we are going to take those limits as well. So this is a very nice application of derivative. For instance, remember we have seen sine x over x as x goes to 0 is equal to 1, but at first it gives us sine 0 over 0, which is 0 over 0, and then when we apply L'Hopital's rule here, we take the derivative of sine of x, then we divide it by the derivative of x, which gives us the limit of cosine x over 1 as x goes to 0, which is equal to cosine of 0, and remember cosine of 0 is 1, and we have seen that this limit was equal to 1 before. Now by L'Hopital's rule we see this again, and as you see this limit is equal to 1, and we just have seen this by using the L'Hopital's rule. Another example is, let's say we have e to the x minus 1 over x. So when x goes to 0, at first we get e to the 0 minus 1 over 0, which is 1 minus 1 over 0, because e to the 0 is 1. So we have 0 over 0. So we apply L'Hopital's rule, which gives us the derivative of e to the x minus 1 divided by the derivative of x. Then we take the limit, x goes to 0. So it is e to the x again, minus 0 divided by 1. And this is just e to the x. When x goes to 0, this goes to e to the 0, which is equal to 1. So this limit is 1. Now, this is an example for infinity over infinity. We have done this again before, and it was a little bit longer. Now, this time it is going to be much faster and easier. So, 6x squared minus 7x plus 12 over 3x squared plus 8x minus 1 as x goes to infinity. So, when x gets very large, 6x squared and 3x squared, they will get very large as well as the dominating terms. So we are gonna get infinity over infinity. So we apply L'Hopital's rule, which means we take the derivative of the top, so that gives 12x minus 7 divided by the derivative of the bottom, which is 6x plus 8. So when x goes to infinity, again 12x and 6x, these are the dominating terms on the top and the bottom. So this limit is gonna be infinity over infinity. So we apply L'Hopital's rule again, because we have another infinity over infinity. So we take the derivative of the top and divide it by the derivative of the bottom. Derivative of the top is 12 minus 7. Derivative of the bottom is 6 plus 0. So we have 12 over 6, which is 2, and this is the result. Now, there are other indeterminate forms, like one of them is infinity minus infinity, 0 times infinity, 0 to the 0, 1 to the infinity, and infinity to the 0. These are other indeterminate forms. So this is an example for infinity minus infinity. Let's say we have 1 over x minus 1 over e to the x minus 1 as x goes to 0 from the right. So when x goes to 0 from the right, 1 over x gets larger and larger, so positive infinity. And 1 over e to the x minus 1, when x gets very large, e to the x term gets very large. So we are going to have, when x goes to 0, e to the x term goes to 1. 1 minus 1 will go to 0, but positively very small. So 1 over positively very small will get infinity. So we have an infinity minus infinity. So what are we going to do? We are just going to combine the terms by making the denominators equal. That's the trick here. Okay. So expand the first fraction by e to the x minus 1 and expand the second fraction by x. So we kind of cross expand by the cross denominators. Then on the top we are now going to have e to the x minus 1 minus x divided by x times e to the x minus 1. So when x goes to 0 from the right, the top is going to be 1 minus 0, which is 0, and the bottom will be 0 times 1 minus 1, 0 times 0, so 0 again. So this is a 0 over 0 now again. So we can apply L'Hopital's rule to this, and we take the derivative of the top. The derivative of the top will be e to the x minus 0 minus 1, and derivative of the bottom, if we apply the product rule there, we are going to get 1 times e to the x minus 1 plus x times e to the x minus 0. That's just the product rule. And then if we combine this denominator term, like it's going to be e to the x minus 1 plus x e to the x. So when x goes to 0, this will go to e to the 0 minus 1 divided by 1 times e to the 0 minus 1 plus 0 times e to the 0. So there will be again e to the 0 is 1, 1 minus 1 will be 0, so the bottom will be 0, the top will be 1 minus 1 also 0, so we have another 0 over 0. Okay, we then apply the L'Hopital's rule one more time. So we take the derivative of the top, which brings the derivative of e to the x minus 1, so it's e to the x minus 0, and derivative of the bottom. So we have three terms on the bottom, like that's e to the x minus 1 plus x e to the x. So when we take the derivative of that, e to the x minus 0, and if we apply product rule for the third term, x times e to the x, we are going to get 1 times e to the x plus x times e to the x, because the derivative of e to the x is e to the x again. So what is going to happen if we let x go to 0 from the right? We will obtain e to the 0 minus 0 divided by e to the 0 minus 0 plus 1 times e to the 0 plus 0 times e to the 0. So e to the 0 is 1. On the top we have 1. On the bottom we have 1 plus 1 times e to the 0 is another 1. So we have 1 plus 1, and 0 e to the 0 is 0. So we have 1 over 1 plus 1 plus 0, which is 1 over 2, and that's the final result. Now there is another example. Let's say we have the limit of x over x minus 1 minus 1 over ln of x when x goes to 1. So when we let x go to 1, we are going to have 1 over 1 minus 1 minus 1 over ln of 1, which will be infinity minus infinity. So we then make the denominators equal by cross expanding. It's going to give x ln x minus x minus 1 divided by x minus 1 times ln of x. By the way, this should have been x goes to 1 from the right. Anyway, so when we make the denominators equal here, it's going to be equal to x ln x minus x minus 1 divided by x minus 1 times ln of x. So when x goes to 1, we are going to have 1 times ln of 1 minus 1 minus 1 over 1 minus 1 times ln of 1. ln of 1 is 0, 1 minus 1 is also 0, so we are going to have 0 over 0. Now, so we can apply L'Hopital's rule. We take the derivative of the top and derivative of the bottom. This is going to give, well, if we apply product rule for the term x ln x, derivative of x is 1 times ln x plus x times derivative of ln x is 1 over x, so we have x times 1 over x. Derivative of minus x minus 1 is just minus 1. So that x times 1 over x, which gives 1 plus 1, and that minus 1 there, just equal sum up to 0. We have ln x on the top only. On the bottom, again a product rule for the terms x minus 1 times ln x. 1 times ln x plus x minus 1 times 1 over x. Okay, so we are going to have, when we distribute that 1 over x on the denominator, x times 1 over x is 1, minus 1 times 1 over x is minus 1 over x. So let x go to 1 again. We will have ln of 1 divided by ln of 1 plus 1 minus 1 over 1, which is ln of 1 is 0, 1 minus 1 will be 0 again, so 0 over 0. Okay, we apply L'Hopital's rule one more time. Take the derivative of the top divided by the derivative of the bottom and take the limit again. Derivative of ln of x is 1 over x, derivative of ln of x is 1 over x, derivative of 1 is 0, derivative of minus 1 over x is minus 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 1 over x, which is plus 1 over x squared. Sorry, it's minus minus 1 over x squared, so it's going to be plus 1 over x squared. When we let x go to 1, we will have 1 over 1 divided by 1 over 1 plus 1 over 1 squared, which gives 1 over 1 plus 1, 1 over 2. Okay? Now, let's see an example with the indeterminate form, infinity times 0. Okay? So, when x goes to infinity, x cubed will go to infinity, but e to the minus 2x, that term is actually 1 over e to the 2x. So, when x gets very large, the denominator will get very, very large. E to the 2x will get very large. So, we have 1 over something very large, which will go to 0. So, that's infinity times 0. This is an indeterminate form. Okay? So, what do we do? Well, we try to make it look like infinity over infinity or 0 over 0, whichever we can do. So, what do? We take that e to the minus 2x term, write it like 1 over e to the 2x. So, then that limit is x cubed divided by e to the 2x. And when we let x go to infinity, this is infinity over infinity, because x cubed goes to infinity, e to the 2x goes to infinity. So, we have an infinity over infinity. Now, then we can apply L'Hopital's rule. Take the derivative of the top and the derivative of the denominator. We are going to get 3x squared divided by 2 times e to the 2x by the chain rule. And then take the limit again. As you see, it's going to be again infinity over infinity. Now, apply L'Hopital's rule again. Take the derivative of the top, 6x. Take the derivative of the bottom, 2 times e to the 2x, which is 4 e to the 2x. Take the limit again, infinity over infinity. So, apply L'Hopital's rule one more time. The derivative of the top will be 6. Derivative of the bottom will be 4 times 2 times e to the 2x, which is 8 times e to the 2x. But when x gets very, very large, positive infinity, we are going to have 6 divided by something very large, which will be very small, eventually 0. So the answer is 0. So we stop when we have some finite number, or maybe an infinity. But if it's infinity over infinity or 0 over 0, then we keep applying L'Hopital's rule. Another example is this one. X times e to the minus x, as x goes to infinity, well, x will go to infinity. E to the minus x is actually 1 over e to the x. When x gets very large, this is going to be 1 divided by something very large, which will go to 0. So this is infinity times 0. So, again, we are going to write that e to the minus x as 1 over e to the x. So we have actually x over e to the x. When x gets very large, this will be infinity over infinity. So apply L'Hopital's rule. Derivative of the top is 1. Derivative of the bottom is e to the x. Take the limit again. 1 over e to the x. When x gets very large, will be going to 0, because the denominator will be very, very large. So we are going to have 1 divided by something very large, which is 0. Now, exponential indeterminate forms. Let's start with 0 to the 0. And let's have limit of this function x to the x when x goes to 0 from the right. So x gets positively very, very small. That means, well, when we let that happen, we are going to have 0 to the 0, which is an indeterminate form. So what do? In these exponential indeterminate forms, we call this limit L. Capital L is the limit we are trying to find. Then take the ln of both sides. So it's going to be ln of the limit L equals limit. It's going to be actually ln of the limit, but then for continuous functions, this is x to the x is continuous. So we can carry ln inside. So it's going to be limit of ln of x to the x. X goes to 0 from the right. But then the purpose of taking the ln of both sides is taking that power inside, outside the ln, and multiply. Remember, we have a property ln of a to the p, some exponential term. Then we can always take that power p and multiply outside. So it's still the same term, but it's going to be equal to p times ln of x. So this term, ln of x to the x, will be x ln x. Now, when we let x go to 0 from the right, what's going to happen? This x ln x will go to 0 times ln of x will go to minus infinity. Why? Because remember the graph of ln of x. When we approach to x from the left of 0, from the right of 0, then the function ln x will get negatively very large. So we have 0 times minus infinity. Okay, this is something we have seen before, 0 times minus infinity. I mean, this minus doesn't matter as long as it's an infinity. It's another indeterminate form. Now, what's the trick again? The first trick was taking the ln, but now the second trick is trying to put this into 0 over 0 or infinity over infinity. How can we do this? Well, the trick is, when you have something like 0 times infinity, and if you have a term like x, you can write it like 1 over 1 over x. Why? Because think about it, like 2 is, for instance, this is just a separate example, like 2 is 1 over 1 over 2, because 1 over 2 is 0.5. So if you divide 1 by 0.5, that's still 2. So you can always write terms like that. Like x can be written as 1 over 1 over x, because you can take the denominator, flip and multiply by 1, which will be 1 times x over 1, which is x again. Okay, so that's the trick. But then our expression will be, instead of x ln x, it's going to be ln x times 1 over 1 over x, which is this expression here. Take the limit of this guy. When x goes to 0 from the right, ln x will again go to minus infinity, but 1 over x function will go to plus infinity. Remember the graph of 1 over x? When we approach to 0 from the right, then 1 over x gets positively very large. Remember, because we are dividing 1 by positively something very small, it's going to get bigger and bigger, positively larger and larger, so it's going to get positive infinity. So we have minus infinity over infinity. Now we can apply L'Hopital's rule. That minus doesn't matter. So take the derivative of the top and divide it by the derivative of the bottom, and take the limit again. Derivative of ln of x is 1 over x. Derivative of 1 over x, which is a power function with power minus 1, x to the minus 1, that's going to be minus x to the minus 2, which is minus 1 over x squared. So a fraction divided by another fraction. Take the denominator fraction, flip and multiply. So it's going to be 1 over x times minus x squared over 1. Simplify this. It's just going to be minus x squared over x, which is minus x. Now take the limit. X goes to 0. Well, minus x goes to minus 0, which is 0. But remember, this is ln of the limit we are trying to find. So if ln of L is 0, then take these ln of L equals 0 equation and write it as power of e. So e to the ln L equals e to the 0. But remember, e and ln function, exponential function e and ln, these are inverse. So e to the ln L will just simplify to L. E to the 0 will be just 1. So the answer, our original limit, is equal to 1. Okay, this is another indeterminate form, which is infinity to the 0. Let's say we have the function x to the 1 over x when x goes to infinity. Then what's going to happen? X on the base will go to infinity, and 1 over x on the power will go to 0. Why? Because 1 over x will smaller and smaller when x gets larger and larger. So we are going to have infinity to the power 0. Okay. Now, what do we do? Remember, if we have exponential indeterminate forms, we take the ln of both sides. So ln of, call this L, take the ln. ln of L equals limit x goes to infinity, ln of x to the 1 over x. Why? Because we can take that power outside. So take that 1 over x and multiply. 1 over x ln x. So take the limit now. When x goes to infinity, remember the graph of ln of x, when x gets very large, ln x also gets positively large. So the numerator is infinity, and x on the denominator will also be infinity. We have an infinity over infinity. So apply L'Hopital's rule. Derivative of ln x is 1 over x, derivative of x is 1. So we have limit of just 1 over x. When x gets very large, 1 over x goes to 0. So we have 0 over 1, which is 0. But remember, this is ln of the limit. ln of L is 0. Again, write this as e to the ln L equals e to the 0, then L is equal to 1, and we are done. Now, this is another example, but with another indeterminate form, exponential indeterminate form, 1 to the infinity. So, this time we want to find the limit of cosine of x to the power 1 over x squared. Okay, when x goes to 0 from the right, cosine of x will go to cosine of 0, and 1 over x squared will go to 1 over 0 squared. So cosine of 0 goes to 1. Remember, cosine of 0 is 1. It will go to 1, but 1 over 0 squared, when the x is positively very small, it's going to go to infinity, positive infinity. It wouldn't matter if it was minus infinity, but anyway. So what do? We take the ln of, we call this limit L, and then we take the ln of both sides. So ln of L equals limit of ln of cosine of x 1 over x to the power 1 over x squared. So that 1 over x squared inside the ln can be taken outside and multiplied. So 1 over x squared times ln of cosine of x. Now take the limit when x goes to 0. ln of cosine of x will go to ln of cosine of 0. Cosine of 0 is 1. ln of 1 is 0. So we have 0 on the numerator. And x squared will go to 0 squared, which is 0. So we have a 0 over 0. So we can apply L'Hopital's rule. Take the derivative of ln of cosine of x divided by the derivative of x squared. Okay, for ln of cosine of x, we have to use chain rule. Remember, if we have ln of f, the derivative is f prime over f, right? So derivative of ln of cosine x, it's going to be 1 over cosine times derivative of cosine, which is minus sine. And derivative of x squared is 2x. So we have on the numerator, we have minus sine x over cosine x, which is minus tangent x. When x goes to 0, tangent x goes to 0. Or you can think like minus sine 0 goes to 0, cosine 0 goes to 1. So we have minus 0 over 1, which is 0. And denominator is 2 times 0, so 0 over 0. Okay, apply L'Hopital's rule again, but the top is minus tangent x. So derivative of minus tangent x is minus secant square x, and derivative of 2x is 2. Take the limit as x goes to 0, secant square 0. But remember, secant is 1 over cosine. So we have secant square 0 equals 1 over cosine square 0. And there is a minus also there. Cosine 0 is 1. So 1 squared is 1. We have minus 1 over 1 squared divided by 2, which is minus 1 over 2. But this is the ln of the limit. So we write this as e to the ln L equals e to the minus 1 over 2. Then this is just L equals e to the minus 1 over 2. Or you can also think of it, well, you can just leave it like this, but you can also think of it like 1 over square root of e. But anyway, as you see, this is how we deal with 0 over 0 or infinity over infinity limits using L'Hopital's rule. But if we have exponential indeterminate forms, then we try to take the ln of the limit. Then this will help us to take down the power down. And then we try to get something like 0 over 0 or infinity over infinity, so that we can use L'Hopital's rule. Okay, so this is how we take care of limit problems using derivative and L'Hopital's rule.